Hey everyone, welcome back to another video. In this video, I'm going to explain how to design a strip footing using this spreadsheet. A strip footing, also called wall footings, are used to support walls along their length. A strip footing is usually designed such that its length exceeds the length of the wall it is supporting. A strip footing is subjected to flexure in the transverse or perpendicular to the wall direction and is generally designed by considering a typical 1 meter strip along the wall length. The main flexural reinforcement is placed at the bottom of the footing in the short direction. In addition to this, it is necessary to provide reinforcement in the long direction. The required thickness of the strip footing is determined based on the one-way shear requirements. It is usual to avoid the use of shear reinforcement by providing adequate footing thickness. Okay, let's talk more about the spreadsheet. In the first part of the spreadsheet, we have a figure that shows the isometric view of a typical strip footing, and two sections. One is showing the footing reinforcement and other is showing the wall thickness, the dead load and live load that the footing is supporting, and allowable soil pressure under the footing. These values should be changed based on the footing that you want to design. You can also change the information such as a specified compressive strength of the concrete, a specified yield strength of the reinforcement, resistance factor for the concrete, factor to account for low density concrete, clear cover to your lower bars, bar size that you want to use as a main flexural reinforcement, bar diameter, and bar area. After we put the required information into the first part of this spreadsheet, the first thing that we want to do is to determine the required width of the footing. And we're going to do that using this equation. First, we need to calculate PS, our service load. That is P dead load plus P live load. And after that, we have to divide this number by Q allowable times B, and this is gonna give us this value. This is the required minimum width of the footing, and rounding it up is gonna give us this value, which is gonna be the same thing here because it's gonna be exactly 1.2. After that, we need to determine the factor soil pressure to be used in the design for shear and flexure. We are going to do that by dividing the factor P by the area of the footing. The factor P that I'm using here is 1.25 dead load plus 1.5 live load. And we divide that by the area of the footing, and this is gonna give us this value. This is our factored soil pressure. After that, we are going to determine the required footing thickness H based on shear design requirement. To determine the effective footing depth, we use a trial footing thickness. Here I'm using 250. And after that, we can calculate the effective depth of the footing and factor shear force at the critical section, which is at the distance D from the face of the wall. Next, we determine concrete shear resistance. To do that, we need beta value. Beta is the factor accounting for shear resistance of cracked concrete. If you want more information about beta, you can refer to your concrete handbook class 11. Here, because H is less than 350, we can use 0.21 as our beta value. And finally, we can calculate VC, which is our concrete shear resistance. As you can see here, our VC is greater than VF, and this requirement is satisfied. One thing that I want to mention here is that this spreadsheet is not taking into account the self-weight of the footing. To do that, we can calculate the self-weight of the footing and add it to the dead load that we had in the first part. Putting this value back into the first part of this spreadsheet, we can get the new required width of the footing, and after that, we have to make sure that the H, which is thickness, is still enough for our shear resistance, and our shear resistance requirement is satisfied. Using the new value that we have for dead load, width, and factor soil pressure, we can now calculate the area of required flexural reinforcement in the next section. To do that, first we determine the factored applied moment at the critical section, which is at the face of the wall. Then we calculate the required area of flexural reinforcement from this equation and compare that with the minimum reinforcement required, and this value will be the maximum of those two values. Then we determine the required bar spacing for flexural reinforcement and make sure that the spacing is less than the maximum permitted bar spacing, which is the lesser of 3H and 500 mm. And this will be the result for our flexural reinforcement. Lastly, we need to design the footing for minimum reinforcement in the long direction. Again, after we found the bar spacing, we compare this value with the maximum permitted bar spacing, which here is the lesser of 5H and 500 mm. Finally, the design of this footing is done, and we need to provide a design summary. We can see the summary of the result of this design on the sketch showing the footing cross-sectional dimension and reinforcement. Thank you guys for watching this video. If you liked the video, hit the like button, hit the subscribe button, and as always, if you have any comments, if you have any question, or if you want this spreadsheet, please comment below and I will get back to you. See you guys in the next video.